good patient diagnosis, quality of diagnostic equipment itself needs to be checked periodically. QCheck is a quality assurance program for measuring the deviations of the various parameters of an X-ray machine from the accepted standards. QCheck is a program evolved by Apt Medical Systems, a company whose staff has been trained and then accredited by Atomic Energy Regulatory Board (AERB) for quality assurance. Apt has an assured track record for 16 years in radiology equipments.
Quality assurance in diagnostic radiology. One of the fundamental goals of a diagnostic radiology department is to get the best image with the minimum amount of dose and cost to the patient as well as the institute. In order to do this, we have to run a quality assurance QCheck program in every diagnostic radiology center to achieve the best results. If the image is of a poor quality, the radiologist will not be able to extract any information from the radiograph, which will necessitate a retake. Retakes result in unnecessary radiation both to the patient as well as the staff. Retakes overload the machine, which will also reduce the life of the tube.
QCheck methodology is based on the standards set by AERB. The test methodology includes conducting tests as per the prescribed procedure, record and analyze the results, and seek corrective actions. Before you begin the test, ensure that the door of the X-ray room displays warning messages of radiation hazards to pregnant women and public in general. The red bulb at the entrance will glow when the X-ray is on. X-ray machine room has a brick wall of thickness 9 inches and the door is lead lined. The machine is kept sufficiently away from the waiting room and the operator wears the TLD badge inside the lead apron. Congruence of optical and radiation field test checks the congruence of optical and radiation fields. If the two are not congruent, the area of clinical interest may be missed in the radiograph, leading to retake and unnecessary radiation to patients. A FFD of 100 cm is selected and the light field is adjusted to coincide with the area marked on the collimator test tool. Central beam alignment test checks if the X-ray beam is perpendicular to the image receptor or not. The test tool is kept along with the collimator test tool such that the lower steel ball is just above the center of the collimator test tool. The image of the upper steel ball must fall within the inner 4 mm circle, which corresponds to 1.5 degrees deviation. Focal spot size test checks the focal spot size of the X-ray tube using the principle of minimum resolution. FFD used is 60 cm. The height of the test tool is 15 cm, giving a magnification ratio of 4:3. Minimum resolvable line pair size and the corresponding focal spot size is obtained by referring to a table. Timer test checks the exposure on time. The meter is kept under the X-ray tube at a distance of 100 cm and exposure taken. Tolerance is 10%. Accelerating peak voltage or the kVp test is to maintain the expected voltage. The kVp meter is kept below the X-ray tube at a distance of 40 to 50 cm and an exposure is taken. The tolerance is plus minus 5 kVp. Linearity of timer test is conducted by keeping the kVp and MA constant. The radiation output is measured at different timing stations. Multiple readings are taken for each timing to eliminate statistical errors. The coefficient of linearity should not exceed 0.1. Linearity of MA loading station test is conducted by keeping the kV and time constant, and the output is measured at different MA stations. An average of multiple readings is obtained. The coefficient of linearity should not exceed 0.1. Consistency of radiation output test is conducted at the same values of MA and timer, and the output is measured at different kVp. The consistency at each kV station is checked by evaluating the coefficient of variation. This coefficient should not exceed 0.05. Total filtration test of the X-ray tube is evaluated by determining the half-value thickness HVT of the beam. In most modern meters, this value is directly available. Total filtration can be determined from HVT using calibration tables. Radiation leakage through tube housing is a test to measure the leakage radiation from the tube housing at a distance of 1 meter from the left, right, front, back, and the top of the tube. Close the collimator fully and take an exposure at maximum kVp and maximum MA allowed at that kVp. The operating time should be greater than the time constant of the survey meter. Based on the measure correct measure principle, the Q-check methodology is the only effective methodology to keep X-ray machines, cath labs, mammography, CT scan and dental X-ray machines from deviating the AERB standards.
Q-check program will help you increase the life of your machine.
Q-check means secure radiation that ensures quality.